This is the AI News Flash for June 20th, 2 p.m. UTC. First up, an AI-designed protein has formed hollow, virus-like nanoscale shells that could reshape vaccine and drug delivery. The work was led by Professor Sangmin Lee of POSTECH in South Korea, together with Professor David Baker of the University of Washington, the 2024 Nobel laureate in chemistry. Using the AI protein structure generation tool RF diffusion, they designed a single trimeric protein unit able to occupy both pentagonal and hexagonal arrangements. As a result, multiple proteins spontaneously bound and self-assembled into spherical shells ranging from 70 to 220 nanometers in diameter. The smallest formed a nano-soccer ball pattern, the largest exceeded it by more than 3 times, and all were verified by cryo-electron microscopy. The paper published in Nature is titled Design of One-Component Quasi-Symmetric Protein Nanocages, because the cages can carry drugs and genetic material inside while displaying antigens outside. They hold promise for targeted drug and gene delivery and for vaccine antigen presentation platforms. Next, a new benchmark called BIM-Edit tests whether large language models can correctly edit building information models. The models are represented in the industry standard IFC format. Rather than generating new geometry, the benchmark evaluates whether an LLM can edit an existing scene using natural language while preserving its semantics and relations. It spans 324 editing tasks across 11 realistic building models and 36 synthetic scenes, grouped into direct, spatial, and topological categories. Outputs are assessed on 3 dimensions: geometric accuracy, semantic validity, and topological consistency. The best performing model achieved only a 49.5% average score across the 3 metrics. Moreover, no model fully solved more than 3.4% of the tasks, exposing a substantial capability gap for structured engineering workflows. Third, researchers have proposed a new metric, the rule violation score, to measure how well predictive models obey logical rules. Traditional metrics such as ranking quality, prediction error, and classification accuracy do not assess whether outputs respect predefined logical or domain-specific constraints. The rule violation score quantifies this logical compliance independently of accuracy. It distinguishes hard rules, which are strict constraints, from soft rules, which are statistical regularities, and it automatically generates SQL queries to verify horn rules. The key finding is that 2 models with comparable predictive accuracy can show substantially different levels of logical compliance, revealing behavioral differences that standard metrics miss. That's all for this AI News Flash.